Now I would like to explain you the frequency response of low pass and high pass RC circuits. So here we are saying that if a sinusoidal waveform is given to the linear circuit, the output wave shape will not change. Sinusoidal waveform, if we are applying to the linear circuit, the output wave shape will not change. First of all, we will look after that one. Here you can observe, this is the input signal. I had taken peak to peak 2 volts, and input frequency is 1 kHz. Again, for that purpose, here I am connecting the low pass RC circuit. Again, input is applied to the resistor one end and output is taken across the capacitor for the low pass circuit. Now if we observe the output, here you can see the output. So this is the output signal, this is the input signal, this is the input signal, and this is the input signal, and this is the output signal. So you can observe the wave shape. The shape of the sinusoidal signal is not changed here. The shape of the input signal, when it is a sinusoidal, it is not changed here. Output signal shape is also a sinusoidal, but it has some effect on amplitude. Amplitude is affected by the circuit. Okay, so here this particular circuit will operate as a low pass RC circuit. Here I am decreasing the frequency. Here. So if I decrease the frequency, here amplitude is somewhat nearly equal to the input signal amplitude, but as the frequency increases, up to cutoff frequency, the amplitude is similar to the previous value, but after cutoff frequency, you can observe here, amplitude of the output signal is decreasing. As the frequency is increases, amplitude of the output signal decreases. That means at low frequencies we are getting the maximum amplitude. Here I am increasing the frequency. Low frequencies means, in the sense, here you can observe this is only 300 Hz I am giving. At 300 Hz amplitude is somewhat maximum. This is the output waveform, this is the input waveform. Amplitude is maximum, but as the frequency increases, 355 Hz, and next 355 after 1 kHz, this is nearly 1 kHz, and again I am increasing the frequency here. So you can see here frequency I am increasing here. As the frequency increases, you can observe the amplitude of the signal is decreasing. So this particular circuit will act as a low pass RC circuit. So these are the sample values. Output voltage, input voltage we are taking 2 volts at low frequency. That means up to cutoff frequency maximum amplitude will be obtained, and after cutoff frequency amplitude will slowly decreases towards 0. Similarly high pass RC circuit, again same thing, we are reversing the components, capacitor and resistor. Input is applied to the capacitor and output is taken across the resistor. Again you can observe, this is the, I am giving from the low values of input signal. So you can observe here, this is input signal, this is output here, input and output. If you observe input and output amplitude is very small. Why? Because the frequency is very low here. Frequency is only 275 Hz. At 275 Hz, the amplitude of the output signal is also very small. Now, if I increase the frequency, now if I increase the frequency, you can observe here amplitude of the output signal is also slowly increasing. Amplitude of the output signal is also slowly increasing to the peak value, maximum value. So this is input and this is output. Again same thing you can observe. When sinusoidal signal is giving as input to the linear circuit, output is also a sinusoidal waveform. And the values, if you observe the output voltages may be like this. When the input signal voltage is 2 volts, at low frequencies output amplitude is very low. As the frequency increases, output amplitude also increases.